Hi, my name is Praveen. My metric number is 10DTP22F1027. Today I'd like to talk about electrochemical process. Introduction for electrochemical process. An electrochemical process is all about the interplay between chemical reactions and electricity. It's where chemical reactions are either driven by an electrical current or conversely, where chemical reactions produce electricity. This reaction involves the movement of electrons between substance and they can't happen without a specific setup. Principle of electrochemical. Electrochemical machining (ECM) involves a series of well-coordinated steps to achieve previous material removal. The iron workpiece is securely positioned on the workpiece holding table, and the tool is brought close to it. Both the cathode tool and the anode iron piece are immersed in a solution of NaCl common salt. The power supply connects the cathode and anode to its negative and positive terminals. The electrode from the reservoir tank is continuously pumped into the gap between the tool and the workpiece with the help of a circulating pump. The tool feed system advances the tool towards the workpiece. These are the machine parts. An electrochemical machine consists of various parts that work together to facilitate electrochemical reactions. One of the key components is the electrode, which is a conductive solution or material allowing ions to flow between the electrons. The anode, where oxidation occurs, release electrons and positive charged ions into the electrode, while the cathode, where reduction occurs, accepts the electron and the negatively charged ions. The power supply provides the necessary electrical energy, and the cell housing encloses and protects all the components. These parts collaborate to enable electrochemical reactions. Two example applications: die sinking and hole control. Electrochemical machining is extensively used for precise die sinking and hole controlling operations in various instructions. The second was electrochemical grinding. By combining ECM with the grinding processor using a negatively charged abrasive grinding wheel, material removal and grinding operation can be efficiently performed, known as electrochemical grinding. Advantages of electrochemical process. Easy production of complex curvature parts. ECM enables the effortless manufacturing of the complex and concave curvature parts using concave and convex tools, expanding the possibilities for intricate component design. Second advantage is versatility in geometries. This machining process allows the production of more intricate geometries using a single connected CNC machine, reducing the need for multiple setups and increasing efficiency. The third is extended tool life. ECM exhibits negligible tool wear, allowing the same tool to be used for producing an infinite numbers of components, leading to cost saving and enhancement productivity. Stress-free machining. With no direct contact between the tool and work material, ECM avoids forces and residual stresses, ensuring precision and minimizing the risk of damage to the workpiece. Superior surface finish. ECM achieves an excellent surface finish due to automatic level dissolution, resulting in smooth, high-quality surfaces without thermal damage. And the last is low heat generation. The process generates less heat energy, making it suitable for heat-sensitive materials and preserving material integrity during machining operations. Disadvantages of electrochemical. The first is corrosion risk. The use of saline acidic electrode in ECM can lead to corrosion of the tool, workpiece, and equipment, necessitating careful material selection and maintenance. The second is high energy consumption. ECM has high specific energy consumption, which can result in increased operational cost. The third is limitation to conductive material. ECM can only machine electrically conductive work materials, restricting its application to non-conductive materials. The next is Incompatibility with soft materials. Soft materials are unsuitable for ECM as the processes may not provide the desired precision and removal of material. The next is space requirements. ECM operations may require a large production floor area, potentially impacting the overall space utilization in the manufacturing facility. The last is health and environmental concerns. The use of electrolytes and potential emissions from the process may raise health and environmental concerns, necessitating proper handling and waste management measures. As a conclusion, electrochemical processes are like magic tricks, where you can turn chemical reactions into electricity and vice versa. They work by shuffling electrons between chemicals, with some losing electrons getting oxidized and other gaining them getting reduced. This electron flow can create electricity like a battery or use electricity to make new chemicals like in electroplating jewelry.
Hi, my name is Tinaraj. My metric number is 10DTP22F1035. Today I want to talk about chemical process. First of all, I want to make a short and simple intro for a chemical process. Chemical process plays role in a manufacturing, serving a backbone for production of a vast array of products that are integral to modern society, from to plastic and from petrochemical to paints. These processes involve the transformation of raw materials, chemicals, substance, and compounds into value finished product through chemical reaction and physical operations. The efficiency, sustainability, and safety of these processes are as they directly impact product quality, environmental footprint, and economic viability. This introduction aims to explore the fundamentals chemical process in manufacturing, examining the key principal technologies and methodologies. And then I want to explain about the principle of operation. They got 4 principles of operation. First one is chemical reaction, second one is base balance, third one is energy balance, and fourth one is transport phenomena. The chemical reaction at the heat of manufacturing process are chemical reaction where reacts are converted into products through molecular transformations. These reactions are carefully designed to control, to maximize yield and minimize unwanted products. The second one is the mass balance. This principle states that mass balance in closed system must be conserved. In the context of chemical manufacturing, this means that the mass of all reactants must equal the mass of all products, byproducts, and waste. The third one is energy balance. Energy balance involves ensuring that all energy entering a process balanced with the energy leaving in the process the form of product, waste, heat. The fourth one is transport phenomena. Chemical process often involves the transport of mass, energy, and momentum. Understanding how these entities move within the system thoughts mechanics like diffusion, convection, and radiation is essential for designing. Now I want to get into the machines, parts, and components of chemical process. First one is reactors. Reactors are the heart of the chemical processing, designed to provide the controlled environment where chemical reacts occur. The second one is heat exchangers. These devices are used to transfer heat between 2 or more fluids, which are crucial for controlling process temperature and facilitating energy recovery. The third one is pumps. Pump moves liquids and sometimes slurries towards the systems. Different types include centering pumps, positive displacement pumps, disparagraved pumps, and paralytic pump, each selected based on viscosity of fluid. The next is valves. Valves control the flow rate, direction, and routing of fluids. Next one is distillation columns, used for separating fluid mixtures into their component parts or fractions based on different invalidities towards a paired separation process. Next is mixer and alligators, essential for ensuring homogeneous mixing of reaction and maintaining uniform particle distribution within reactors. Next is pressure vessel, container designed to hold gases or liquid at a pressure substantially different from ambient pressure. Next is storage tanks, used for storing raw materials, intermediates, and final products. After that, control system. Control system including sensors, actuators, and PLCs, programmer logic control, are integral for monitoring process variables like temperature, pressure, flow rate, and chemical concentration, ensuring the process stay within specific parameters. Then, the last one is safety system. Includes pressure relief valve, emergency shutdown system, and venting system designed to mitigate the risk of chemical reaction running out of control. I'm moving to next key point of chemical process. Application of the machining process of chemical process. The first one is fabrication of equipment. Many components of chemical processing equipment require precision machining to meet strict specification of functions and safety. The next one is customization of parts. Chemical process often require unique solution or custom designed parts to handle specific reaction of materials. And then the third one is surface treatment and finishing. Machining process like grinding and polishing are used to achieve the required surface finish on metal parts. Then is the creation of sealing and containment features. Gasket seals the other containment features often need to machine to exact dimensions of ensure tight seals in process equipments. After that, repair and maintenance. Wear and tear on equipment are common in chemical plants due to corrosive and abrasive nature of mechanicals. Then, prototype development. Before full-scale production, chemical process often require prototype testing. Machining instrumental in creating these prototypes, allowing to rapid testing. The seventh one is integration of new technologies. As new technologies and materials are developed, machining and process are needed to integrate this into existing chemical production system. The last one is safety enhancement. Machining can be used to produce components that enhance the safety of chemical processing equipment such as pressure relief system and explosion-proof housing of electrical components. Now I want to tell about the advantages of chemical processing. I got 5 advantages from my studies. The first one is efficiency on production. Chemical process can produce materials and products at scales which manual or other form of manufacturing could not achieve. This efficiency translates to lower cost and higher ability of products. The second one is creation of unique materials. Many materials essential in modern life, such as polymers and advanced ceramics, can only made through the chemical process. The third one is resource optimization. Chemical process often allow for maximal extraction and use for raw materials, reducing waste and improving yield through catalytes and other means. The fourth one is energy production. Chemical processing is the key production of fuel and energy, including petroleum refining and processing of biofuel. The last one is technological innovations. Advanced chemical engineering and process technology often lead to improved products and new technologies, fostering further innovation across industries. If they got advantages, they must got disadvantages. So, I get 6 disadvantages. The first disadvantages is environmental impact. Environmental impact. Chemical process can produce significant amounts of waste and emissions, contributing to the pollution and climate change. The second one is energy consumption. Many chemical processes require some substantial amount of energy, which can contribute to overall energy demand and the environmental footprint of production. The third one is safety risks. Chemical manufacturing involves handling hazardous materials, which can pose risks of leaks, spills, explosion, and other industrial accidents. The fourth one is health hazards. Exposed to chemical can pose health risks to workers, necessitating robust health and safety measurements, personal protective equipment, and training to imitate these risks. The fifth one is complexity of cost. Designing and operating and maintaining chemical plants involves significant investment and high operational costs due to the complexity of chemical reaction and need for chemical specialized equipment to skill the personnel. The final one is the regulatory and compliance issues. The chemical industry is highly regulated with stringent standards for production, waste management, and emissions. Compliance can be costly, requires constant monitoring, adaptation to new laws. Now I want to conclude the chemical process. The preceding pages have addressed with a wide range of issues related effective medical response to acts the chemical or biochemical terrorism. The chemical process is very dangerous and they got a lot of advantages and disadvantages. So that we need to learn and train it before use the chemical process to avoid any accident happens. That's all from us. Thank you.
Welcome to Academic Gain Tutorials. In this video, we will look into the differences between chemical and electrochemical machining. As the name suggests, chemical machining employs an appropriate chemical solution to etch away material from work surface. Such chemical solution is called etchant and is highly corrosive. No separate cutting tool, shape tool or similar device is used here. On the other hand, in electrochemical machining, material is removed by ionic dissolution but under the assistance of electrochemical reaction. No corrosive etchant is used here, instead, a suitable electrolyte is employed. So, let's look into the basic differences between chemical and electrochemical machining in a tabular form. Difference number 1. As the name suggests, chemical machining is one chemical energy-based non-traditional machining process, whereas electrochemical machining is one electrical energy-based non-traditional machining process. Number 2. In chemical machining, material is removed in ionic form due to controlled dissolution by chemical etchant. etchant slowly dissolves metal to realize machining, whereas, in electrochemical machining also material is removed in ionic form but due to controlled electrochemical dissolution of work metal. Number 3. Chemical machining is independent of electrical conductivity of workpiece metal. So it can be applied for conductive and non-conductive materials, whereas, in electrochemical machining, the workpiece must be electrically conductive as it is used as anode of the electrolytic cell. Number 4. In chemical machining, no additional electrode is necessary as the chemical reaction takes place between etchant and workpiece, whereas, in electrochemical machining, an electrode having curvature according to intended shape is absolutely required to complete the electrical circuit. Number 5. No power supply is necessary as the process is not related to electrical energy in chemical machining, whereas, in electrochemical machining, one DC power supply is required to maintain desired potential difference between cathode, tool electrode, and anode, workpiece. Number 6. In chemical machining, suitable etchant, based on workpiece material, is employed. Typical etchant include ferric chloride, copper chloride, ferric nitrate, nitric acid and hydrogen fluoride, whereas, instead of etchant, appropriate electrolyte is applied in electrochemical machining. Typical electrolyte includes sodium chloride and sodium nitrate. Number 7. In chemical machining, the rate of chemical dissolution is very hard to control. Once the process is initiated, the rate cannot be controlled accurately anymore, whereas, in electrochemical machining, rate of electrochemical dissolution can be controlled during machining simply by adjusting inter-electrode gap and current. Number 8. Chemical machining cannot inherently control the area from where material should be dissolved. Material is removed wherever the work surface is exposed to etchant. Thus mask can be separately applied to control exposure, whereas, electrochemical machining process can inherently control the area from where material should be removed. Dissolution occurs only from the areas where tool is in close proximity. And, difference number 9, in chemical machining, chemical etchants are highly corrosive and thus the process possesses a risk to the operator, whereas, in electrochemical machining, the etchant is not such corrosive and thus the process is somewhat risk-free towards operator.